Well, hello. Today, I want to tell you that we still got potential. So this is part two. We are going to talk about some conceptual understanding in the physics department that is related to neurobiology. Um, so we have something called the electric field, right? And the electric field in physics is kind of different from, let's say, the word field in physics is a bit different from the word field in our day-to-day life common understanding. And so if you imagine a soccer field, even if there's no players on the field, there's nobody, no human beings on the field, it is still a soccer field, right? Because it exists, you can see. And if we believe seeing is believing and seeing is reality and not a hallucination, this is another entire philosophical discussion. That yes, the soccer field exists regardless whether there is a player or not on the field. But if we look at physics, in physics, we have different charges. We have different, say, things, let's call them things, that have charges. Some are positive, some are negative. And those things together composes an electric field. Without those charges, we wouldn't have a field. It's kind of like the world. Without you and me, we wouldn't have this world. We together on this earth, in this universe, on this timeline, compose this world. And there is electric potential energy, and that potential is kind of related to the potential we're going to talk about in neurobiology. But basically, if we want to calculate the electric potential energy, is how do we move this thing, this blue thing, from A to B? And that's it. You can simply imagine it as, okay, if I have to walk to a sushi bar and that is like 500 meters away from my current position, how many energy, how many calorie I would burn in order to move from my current position to the sushi bar, the next position. And basically, an electric potential function is a function that maps the potential energy per unit charge across a region in an electric field. Let's say we're in a suburb called A, B, C, right? This is a field. And we basically have a function of mapping, okay, here is a person. How do I go to all of these places? You can simply understand as that. Or if you are good at math, we can understand a function as this. A function of taking one input called x, right? And maybe inside the function, it's just x plus 1. And so we're mapping, say, 1, 2, 3, 4, 5, 6. And the output of the function would be 2, 3, 4, 5, 6, 7. So don't think too much about the math inside of it, but simply understanding that it is a function that created this beautiful map here. And basically, a voltage is a difference, let me see here, of electrical potential between two positions, right? Imagine we have this whole field mapped. And here we have 0, and here we have 25. Sorry, that's 50. And maybe the difference, the voltage, is 50, and that's it. And also, we have something called direction in physics. Basically, it is all represented in vector format. And I think it's better to simply understand it similar to a wind map, right? So if you love geography, basically the wind flows from high pressure to low pressure, and this that gives us this beautiful map of where the wind is going. And you can understand that same thing as the sea current, the internal workings that cause the sea current, the ocean tides, are a little bit different from the wind, but you can see that it is still give us energy direction. Where is the water flowing? And I think simply understand these concepts is enough for the next part. And if you say, okay, all of this doesn't matter to me, I'm still confused. This is just not working for me, this analogy. I think the most important thing are these two parts, right? One is the definition here. Let me just highlight it again. The definition here, a voltage is a difference of electrical potential between two positions. And you can just understand electrical potential as a calculated value, and just like 10 or 5, and the voltage is 5. Or sometimes it can be negative if the position has to be reversed. And next would it be the general physics law, that is the opposite attracts, which is opposite of the dating law, that is the similar attract. Anyways, sticks to physics. Opposites attract, and the same would repel. And hence that works well with, say, okay, high pressure, low pressure, opposite. And hence you kind of like low pressure attracted the wind from the high pressure, causing the wind to flow. And same as the sea current, the sea water often flows from like low temperature to high temperature, if I remember correctly. And that's it. That's all you need to know for the next part, is that the voltage is a difference of value between two positions, and the opposite attract, the same repel. And that's it. I will see you in part 3.